I can promise you, if I was the IE on this line and I would have to go to that station, then that operator would have probably performed much different.
Or you'd never notice it.
Or you'd never notice it.
Because there's whatever, 7 or 8 operations that happen in the station.
Exactly, yeah.
So welcome to another Thursday Thought. Today I'm with Jeannie, who's an industrial engineer with almost 5 years worth of experience. I want to ask Jeannie a couple of questions. Jeannie.
Yes.
What are some of your biggest challenges when assessing the performance of a production line?
Definitely the first thing that comes to mind is obviously the data collection. So that is something that can be very long and tedious, and it takes forever in terms of having your stopwatch, standing on the line with a clipboard and watching operators. And where the tedious part comes in is actually capturing that information generally on an Excel sheet. That's everybody's go-to, right? Yeah. And then you try and tell the story. But when you start telling that story of what this data actually contains, it can generally lead to you realizing that information might either not be relevant anymore, or the other thing could be that, you know, the operator didn't give you the right information when you're actually recording the time, because they know you were standing there. So that bias can also creep in.
So how much time do you, if you had to say your day was 100%, how much of your day would be typically gathering data, analyzing data, and actually
oh gosh, yeah. So generally you would start out what you call Gemba, where you go to the shop floor and you actually see what's happening and what's going on the shop floor, because it's very important for you actually to understand the process. So that would actually take days. You can't just spend a day on the shop floor and then you think you know a process, because throughout a week there might be each day something different that happens that can cause variation in that process. So you really need to understand. So I would say 2-3 days at least, to spend time just understanding what's happening. Then you start sort of writing down step by step what is actually happening in terms of the process, and I'm trying to understand what are the situations, the ad hoc situations that can creep in, and that would probably be a day or two in itself, because then you go back and then you watch the process again. Oh, I forgot to add this, or oh, I forgot to add this. And then you actually, when you start doing the time study, you obviously have to gather enough information to base it on a proper to have a proper basis. Sorry. So yeah, I would say up to a week maybe for just the data gathering.
Wow.
Then you actually go to an Excel sheet. Now you have to start inputting that information. And as you would know, when you are busy with the process, that's when you actually start realizing, okay, I might have missed this, or this is something I didn't take into account. And then you need to go back and make sure, because what's so important about time studies specifically, that part of data analysis, is they will base everything that you give them, they will compare the operator to that and keep them to that standard. So it's really important that you take into anything that can happen and anything that can affect the operator at the end of the day. That's why even if the operator thinks they are helping themselves by rushing something, while you're standing there, they're actually shooting themselves in the foot, because now you're going to record that time, and that's the time that you're going to give your manager or whoever, and that's what the operator is going to be held against. So it's really important. So in terms of that analysis, I would say probably another 2 or 3 days. It can really, and then you have to go back, and now you bring in that standard into the process. Now you have to go back to the operator and say, hey, maybe we can try doing it a different way. And then, that's when the kickback starts, and you have to convince the operator and implementing that standard. And once you implement a new standard, the whole cycle starts over and over again. That's pretty much just one part of it.
So Jeannie, if you had a day of 8 hours,
yes,
how much time do you think you actually spend problem solving? Because I would imagine that's why you studied industrial engineering, is to actually solve problems.
Yeah. So that's actually, I don't call it problem solving, I call it firefighting, because it's only when, the line is stopped and, stuff is happening that you get called, and it's now you have to take action. But actually getting to the part where you actually gathered the information and now you can make a proper analysis, it doesn't, I won't even say a shift, maybe at the end of the week when you had gaps here and there. And I mean, whenever somebody asks me what is industrial engineering, I just say it's a way of thinking, because that is a way of thinking. But we don't get to the thinking part.
Okay. That's unfortunate. So you've obviously spent time looking at Odin Insights.
Yes.
Maybe show us one or two things in Odin Insights that make sense.
So some of my favorite reports on this is especially the cadence report. So on the cadence report, where you can get a very nice overview of your parts, your okay parts, your not okay parts, but then you can really dive down deep into each and every process or station that you have on your line. Yeah. So each of these cadence graphs for each station actually shows you where your okay parts are for the first time through and for the not first time through. And I mean, on a production line, that is obviously very critical, because those parts that are not first time through obviously also take up many resources. Then we've also got the not okay, which is obviously very critical. And then you see these ad hoc situations where you can actually see where the operator logged, there was certain downtimes. If you have staff downtime, you know it's more logistics related. If you have your block downtime, it might have been a breakdown or something that happened. And unspecified downtime is obviously something that you would want to rule out at the end of the day, because you can't do anything with information that you don't actually know what happened. But what's really nice about this as well, for you to get sort of like an overview of what happened on your line, you can immediately focus on the station where you had problems and for the time that you actually selected. Maybe going. Let me go. So the other one that I would also really like to focus on is maybe the live feed. Okay, so the other report that I also really want to focus on is the live feed, especially focusing on the lean manufacturing way of how those methodologies works. It's on information that's based on the right now. Yes, you obviously get a little bit of a trend looking at previous and historic data, but it's obviously much more efficient and effective on focusing on what's happening right now. Almost a little bit like the firefighting, but you at least have the information from what happened before as well on other reports, like your 100-day report. Where you can go back and just validate the problem that you are seeing right now. So that also helps a little with that firefighting. Personally, one of my favorite reports is the duration report. So the duration report, let me just pick a station here, and I can actually filter it down to the specific shift as well. And this is where we get into the operation information, and which is really critical and something we as IEs focus on quite a lot. So you've got, it's really like quite a mouthful, but even just looking at this graph over here, where you actually get your cycle time versus your idle time, and you can actually see where it peaks and where you have those ad hoc situations, and then where you actually have the cycle time limit as well. And some people might refer to it, or some customers would prefer to see it as their takt time, but no matter what you refer to that as, it gives you that reference.
So what I'm seeing over here is obviously the last, is it 1,000 parts?
No, it's the last day.
The last day's production?
The last day's production,
and,
yes.
The green is obviously the actual cycle time, and the brown is?
The idle time. So it shows you where there wasn't a part in the station itself.
And obviously the chart below is obviously the individual operations in that station.
So this is very beneficial in the part of the process where you would actually have to go in that when you do a time study and you have to break the actual process down step by step, you can see the individual processes, where here we already have a time study of each of those individual processes that took place, and we can clearly see that this blue one is definitely spiked a few times, and
that's where you need to focus.
Exactly. So it brings your attention immediately to what you need to know, so you can start thinking about the analysis
and solving the problem.
And solving the problem, absolutely.
Yeah. So this is the power of having data at your fingertips.
Exactly.
Makes an industrial engineer's job much easier to actually get to solve a problem.
Exactly. No more clock stopwatches for me.
And I guess this is the opportunity for things like artificial intelligence and AI to actually predict cycle times.
Exactly.
And trend when a cycle time, like I can clearly see over here, the cycle time towards the end of the day started increasing significantly.
Yes.
It started out okay, and then it started going a bit slower for some reason.
Exactly.
And that's all live information, and I can see that straight away. Kini, thank you very much.
Thank you, Janesh.
Here's another closing thought.